Hi everyone. Okay, let's go over the exercises that I assigned for chapter 11. So let's start with section 11.2, and I assigned question number 1. So this problem demonstrates the dependence of an annuity's future value on the size of the periodic payment. Okay, so of course the value of the accumulated funds at a future date is going to depend on how much you put in when you make the payments, right? So the examples that they're giving here, everything else held equal, we have payments of $1,000 each year, $2,000 each year, and $3,000 each year. So using the information that we have, again, I advise you to always write it down, okay, what you have. So we know the IY, so IY equals 4. We know that the M, the number of payments per year, is 1, and that the compounding per year and the payments per year are equivalent, okay, so it only happens once a year. We know that N, because it's once a year for 25 years, we know N equals 25. We know we're starting with 0, so present value is 0. And we know that the payment is 1,000. So we need to put in 1,000 plus or minus to, and then put in the payment. And then after entering all that information, you're going to hit compute future value, and it's going to give you an answer of $41,645.91. Okay, so as we've mentioned as well, once you're putting more information or new information into your calculator, whatever information is the same from the previous question, you don't have to re-enter it. Your calculator remembers that as long as you don't clear your work. Okay, so because A had 4 as the IY, the payments per year as the 1, the N as the 25, the present value as 0, those don't have to be re-entered. You can re-enter them if you want, but the only thing that needs to be re-entered is the 2,000. Click the plus or minus button so that you have minus 2,000 on your screen. Then click the PMT button so it recognizes that now everything else is still the same except the payment, and then compute future value. And you'll have the answer of $83,291.82. And for part C, again, it's the payment that has changed. So you're going to put in 3,000 plus or minus to get it to negative 3,000 on your screen, PMT, and then compute future value. Okay, so for the next question, we have number 7. Aaron contributes 2,000 to his RRSP, so the Registered Retirement Savings Plan, at the end of every half year, so semi-annual. What was the value of his RRSP after 12 and a half years if the RRSP grew at 3.5%? Compounded semi-annual? So again, you can see here that your CY and your PY, your payments per year and your compounding per year are the same. So when you put it into your calculator, we have 3.5 IY. Okay, then you need to go to the second level. So you want to hit second IY to get to the PY level, and you put in 2, enter. If you want to arrow down, it'll show you that CY is also 2. So as soon as you change the payments per year, it automatically changes the compounding per year. Once we get into the next unit, you'll see that sometimes they're not the same, but for these examples they are. So For the next one, so you have to put second quit to come back up to the main level on your calculator. Then we have 25N, and that's because it's semi-annual for 12 and a half years. So 12.5 times 2 gives you an N of 25. Again, we're starting with 0. So 0 for your present value. We have payments every half year. So it's 2,000, the plus or minus button, so that on your screen it shows negative 2,000. Click the PMT, because those are the payments that you're going to be making. And then CPT, the compute future value, and it's going to give you the answer of $62,054.92. And question 11. Assume that your client invests 1,000 at the end of each of the next 3 years. The investment earns 4% compounded annually. So again, the payments and the compounding are exactly the same. So your CY and your PY are the same. They're both 1. Okay, so what is the future value at the end of the 3 years? So again, we go through the question, figure out what we know. We know that our payment is 1,000. We know that our N is 3 because it's 3 years, and then it's only once per year. We know that our IY is 4. So we go 4 IY, then go to your second level, second IY, that takes you to your PY. You want to at 1 enter. And if you want to arrow down, you can see that your CY and your PY are both 1. Then we want second quit to come back up to the main level. 3N, 0, present value, 1,000, the plus or minus button, PMT, and then compute future value for a future value of 3,121.60. So you've put 3,000 in over a period of 3 years, and you have interest of $121.60. Okay, so now let's go to the next section, which is figuring out the present value. So the previous section was figuring out future value. Now we want to figure out present value. Okay, so the problem demonstrates the dependence on the annuity's present value, again, on the size of the periodic payments. Calculate the present value of 25 end-of-year payments of 1,000, 2,000, and 3,000. Use the discounted rate of 5% compounded annually. Okay, so let's figure out what we've got. We know that our IY is 5. We know that our PY is 1 because it's only at the end of the year. We know that our N is 25 because it's once a year times 25 years. We know that in this example, our payment is 1,000. And we know that our future value is going to be 0. So we want to completely deplete the annuity at the end. So we want 5 IY. We want our PY to be 1. We want 25N, 1,000 PMT, 0 future value, and then compute present value. Okay, and it's coming up with a present value of negative 14,093.94. Okay, so what's going on differently here is, if you notice, you put the payment in as 1,000 instead of negative 1,000. Because what we're doing is we want to know, okay, how much money do I need to have put into the annuity? So taken out of our bank account and given to an investment. So that's the negative amount. So that's why your present value is negative. And then the payment means that you're getting $1,000. Okay? So every year you're getting $1,000. That's why that payment is a positive number. Okay, so again, everything stays the same except for the amount that you're getting from the annuity on an annual basis. So therefore, your present value is negative 28,187.89. And for C, if your payment is $3,000 annually over 25 years, then the amount you have to have in your present value is $42,281.83. Okay. So a contract requires end of month payment of $175, so end of month, so it's monthly, and the payment is $175 for another 8.25 years. What would the investor pay to purchase this contract if she requires a rate of return of 3% compounded monthly? Okay, so what have we got? We know that it's end of month, so therefore it's 12 times. So if we want to figure out our N, it's going to be 12. Multiply that by 8.25, so our N equals 99. We know that our payment is $175. We know that our IY is 3. And we know that our payments per year and our compounding per year is 12. Okay, so we want to make sure that our PY and our CY are equal at 12. So when we put it in our calculators, we have 3 IY, and then in order to make sure your PY and your CY are 12, you want to go to second and then click the IY button to get to the PY level. 12, enter. And then if you hit your arrow down, you can see that your CY is also showing 12. So once you know that those are set at 12, you can hit second quit to come back up to the main level of your calculator. Then you have 99N, 175 PMT. Future value is going to be 0. So therefore, compute present value. The answer is $15,330.60. All right. And our final question, what is the present value of end of quarter payments of $2,500 for 7 years? Use the discount rate or the interest rate of 6% compounded quarterly. So again, our payments and our compounding is equal. They're both at 4. So we need to make sure that our PY and our CY are set at 4. So we have 6 for our IY. Go to our second level. To go to our PY, we want to make sure it's 4. So enter. You can arrow down to make sure that your CY is also set at 4. And then you want a second quit to come back up to the main level. 28N. Because it's 4 multiplied by 7 years. Your payment, 2,500 PMT, 0, future value, compute, present value. Your answer is going to be $56,816.79. Let me know if you have any questions on these. Please make sure that you're able to get it put into your calculator and come up with the right numbers. Thanks, everyone.